Hello, welcome back. In this video we're going to talk about differentials. Now differentials are very similar to the video on linearization, so if you haven't seen that video, please go check it out. So what's happening here is we have a function f of x, which I'll put right here, f of x. And then we have, this is actually the linearization, or we call it the tangent line at a. So this is the point A right here. So what I want to do is I want to estimate this value. Now if this value, the y value here, is f of a, what I want to do is I want to move over a little bit away from a, specifically a distance of delta x. So delta x is supposed to be pretty small. And what I want to do is I want to find the y value at this x value. So that would be f of a plus delta x. So this is the y value I want. Now if you watch the linearization video, you know that linearization and differentials are going to give us that y value, which is the estimate. Now based off of, based on linearization, it was about the tangent line, finding the point on the tangent line. Now for us, notice that this difference between f of a and this y value is just a little bit of a change in y. We call that delta y. Now that's the true change between these two y values. Now again, this line right here, that's f of a. But what I want to do is, I want to write this first actually. The f of a plus delta x is f of a plus delta y. So I'm just going to find the y value at a, and then I'm just going to add that little extra y, and that's going to give me the y value I'm looking for. The problem is that I don't know this. This is the true change in y. So instead, I'm going to find this. Now this is dy. dy is the estimate change. So I'll write that estimate change in y. So what we have is, instead of f of a plus delta x equaling this, it's going to be approximately f of a plus, and now it's dy. So back with linearization and with differentials, you need a starting point, which we're going to start at a. And we're supposed to know f of a. It's supposed to be nice. Okay. And this is supposed to be the complicated one. So if I can figure out a way to find dy, then all I'm going to do is add that to f of a, and there we go. We have the y value I'm looking for. So how do I find out what dy is? Well, you know that dy dx is f prime of a. F prime of a would be the slope at this point right here. Well, now what's dx? Remember, dx is a change in x. In fact, it's going to be this. This is dx. It's actually the same as delta x. So dx is the change in x, and it's a variable. Now what I'm going to do is I'm going to multiply this dx over to the other side. Now I'm going to get dy equals f prime of a. Oops, sorry. That would be dx. Now this is my differential. Okay, so this is going to be the estimated change in y. It's going to be based off of these two things. dx is the change in x, and this is the slope at a. So let's go ahead and see how we use this. Let f of x equal the square root of x, and I want to find the differential dy. Now the formula for dy is f prime of a dx. Now I don't actually have an a, so right now this is just going to stay some arbitrary a. But I need to know f prime. Okay, so we're going to go ahead and find f prime of x. Now the derivative of the square root of x, this is probably something you should just memorize. The derivative is this. So then what's f prime of a? It's simply 1 over 2 root a. Just plug x equals a in, and there you go. So what's my differential? 1 over 2 root a times dx. So dx is actually our variable. All right, this is going to represent how far we're moving away from a. And that's it. That's our differential. So let's go ahead and see how we can use it. Now we're not going to use linearization anymore because we did that in the linearization video. We're going to use differentials. So let's see how we use it now. Estimate the value of the square root of 17. Now, we do this all the time. We say, okay, well, what's the square root of 17? Well, it's pretty close to the square root of 16, which we know is 4. So we know that it's going to be slightly bigger than 4. Now that's slightly bigger, what I just said, that's going to be my dy. I got to figure out what that change is. So we need a function to use. I'm going to use the square root of x. And I'm going to use, now you need a starting point. A is your starting point. It has to be a good point, meaning that when you plug it into your function, you should be able to evaluate it. So we want 16. Like, you don't pick 15 because the square root of 15, that's not nice. We couldn't do that without a calculator. All right, so a is 16. That's our starting point. Let's take a look at the graph. So here's our a, and I want 17. Now notice that here's the square root of 16, here's the square root of 17. So that's going to be my change in y. So let's go find dy. We already know that dy is this. And we just said a was 16. Now what's dx? Dx is the change in x. If I'm starting at 16 and I'm going to plug in 17 into this function, to get the square root of 17, then my little change in x is just 1. So then dx is 1. So let's go ahead and figure this out. We're going to have 1 over 2 root 16 times 1. Now that's going to be 1 over 8 times 1, which is just 1 over 8. So that means the square root of 17 is approximately the square root of 16 plus my dy, my little change. So that's 4 plus 1/8, which is 4.125. Okay, so that's the estimate for the square root of 17. Now you can check your graphing calculator or scientific calculator, see how close we are. We're pretty close. Alright, so we're going to again use differentials here to estimate the value of the square root of 15.5. Alright then. We still need a function to use. I'm going to use the square root of x again. 16 is going to be our a. 15.5 is sitting about right here. So that means I have this little change here. That's going to be my dy. Now I know the square root of 16 this is 16 comma 4. And I know that this is going to be a little bit less. Now what's dx? Well, if a is 16 and dx is that little change, notice that we are going backwards. So it's a change of 0.5, but it's negative because, again, we went backwards. So negative 0.5. Oops. Well, we know, let me rewrite that. That is dy equals 1 over 2 root a dx. Okay, we know a, 16. We know dx. It's negative 0.5. So let's go ahead and plug that in now. It's going to be 1 over 2 root 16 times negative 0.05. Nope, sorry. Negative 0.5. So that's 1/8 times negative 0.5. And that ends up being negative 0.00 0.625. So that means the square root of 15.5 is roughly the square root of 16 plus dy, which is 4 minus 0.00625. And you plug that in and you're going to get 3.99375. And if you plug it into your calculator, the square root of 15.5 on the calculator is 3.937 and some more stuff. So we're pretty close. At least we're good up to that first decimal. And that's it for differentials. So I'll see you in the next video.